Welcome back. In this video, we're going to take a look at factoring trinomials. One thing to keep in mind is factoring is the reverse of multiplication. So let's take a look at multiplying. Now keep in mind factoring a quadratic is the reverse of FOIL. So when we multiply, we FOIL. Okay, so we multiply the first, the outer, the inner, and we've been video bombed. No, you're in it.
Yay!
So,
Victory!
part of FOIL, we have the smile method. To do the inner and the outer terms, we have 5 times x and 3 times x, and we will add those two together. We have x times x is x squared, and 5 times 3 is 15. And you'll notice that the linear term here, when we add all this together, x squared plus 8x plus 15 and complete our FOIL, that linear term is the sum of our two factors of 15. So 5 times 3 is 15, and 5 plus 3 is the 8. And we see that when we multiply, that's what happens. So when we factor, we have to look for the reverse of that. So let's take a look at some samples. So in x squared plus 9x plus 18, we want factors of 18. We want factors of 18 that add up to 9. So let's take a look. Factors of 18 are 1 times 18. Or 18 times 1. It isn't going to matter. And the sum, of course, is 19. And there's 2 times 9. The sum is 11. And we're going to do positive 1, positive 18, positive 2, positive 9, because we got a positive 18. And what about 6 times 3, or 3 times 6? Well, that sum is 9. So let's take a look. Factors of x squared are going to be x times x. So when I FOIL that back, I'm going to get x squared. Factors of 18, again, if we look, we had 5 and 3 up here. Those were factors of 15. Factors of 18 are 3 and 6, and they're going to add up to 9. And it doesn't really matter where we put the 3 and where we put the 6. And they're both going to be positive, because everything in our trinomial is positive. And let's just double check our linear term. Check the smile, if you will, the inner and the outer. So we have 6x plus 3x is 9x. That matches up with our 9x. So then we have correctly factored x squared plus 9x plus 18 is x plus 6 times x plus 3. Now we can do the same thing with x squared plus 10x minus 45. We need factors of 45 whose sum is positive 10. Well, we have to be careful here, because factors of negative 45 means one's going to be positive and one is going to be negative. And since our sum has to be positive 10, that means our positive factor has to be 10 more than our negative factor. So factors of 45, generally we start with 9 times 5. 9 times 5 is 45. I would use a positive 9 and a negative 5. But our sum is only plus 4. So that's not going to work. I could try 10 and, well, I can't do 10. I could try 15 and 3. It's possible. I've given you one that is prime. I'm trying to think. Negative 15 and positive 3. Well, I do a positive 15 and negative 3, pardon me. That is a positive 12. I've given you one that is prime. Let's keep on moving. Let's look at x squared plus 5x minus 36. So again, I want to find factors of negative 36. that sum is positive 5. So factors of negative 36 are 12 times 3. Well, that's not going to work. Positive 12 times negative 3 is negative 36, but that sum is positive 9. And 9 times 4, that is 36. And if I use a positive 9 and a negative 4, my sum is positive 5. So I set it up as a pair of binomial factors. I know x times x is x squared. I do plus 9 minus 4. And if I check my linear term, 9x minus 4x is 5x. As I like to say, she smiles. And we have factored correctly. In our next example, x squared minus 14x plus 33. Now we have a positive 33 that add up to a negative 14. Well, a positive times a positive would give us a positive, but also a negative times a negative. So our factors in this one are going to both be negative. So, and a negative 3 times a negative 11 is a positive 33, and our sum is negative 14. So we have x times x is x squared minus 3 minus 11. Let's check if we factored it correctly. Let's check the smile part of our FOIL. Negative 3x minus 11x is negative 14x. That matches. So, as I tell the boys I teach, you want to make the pretty girls smile. So, let's check to see if it factors, and sure enough, she smiles. So you factored correctly. We can do factoring with multiple variables here. We've got x and y. So this isn't too bad. We need factors of x squared are x and x, and factors of y squared are y and y. But now we need factors of positive 30 that add up to negative 13. That's like our previous problem where we had a positive 33 and a negative linear term. Here we have a negative linear term, so we know that both of these factors are going to be negative, and it looks like negative 10 and negative 3 would give us a negative 13, and 10 times 3 is 30, so she smiles. We factored that correctly. Here we have a little bit higher power, but x to the fourth, we could use x cubed times x to the first, but our linear term is an x squared, so we know that it's going to be x squared times x squared. Our linear term and our constant are both positive, so we know that's going to be a positive times a positive. And I need factors of 21 that add up to 10. Well, 7 times 3, that's 21, and 7 plus 3 is 10. So I've got factors of 21 that add up to 10, and we factored correctly, and we check our linear terms. 7x squared and 3 times x squared is 3x squared, and we get 10x squared, and sure enough, she smiles. In our last two samples, here we have x cubed and x squared and x. This is a little bit different twist. Going back to what we've studied previously, we can take out the greatest common factor. And in factoring, if you can take out a common factor first, that will make your life a lot easier. So we take out the common factor x. We're left with x squared plus 3x minus 4. We bring down the x. We don't divide out the x. We bring it down. And factors of x squared will be x by x. Now we need factors of negative 4 that add up to positive 3. We know one of our factors is going to be positive, one's going to be negative, because a positive times a negative is a negative. And our larger one is going to be positive, or the absolute value of our larger one. So 4 and 1 are factors of 4. And sure enough, we have 4x minus x and we get a positive 3x. So she smiles, and we have factored correctly. In our final problem, while we have x to the 5th, x to the 4th, x to the 3rd, and 5 and 25 and 30 are our coefficients. Well, those are all factors of 5. I know I can take out a 5, and I can take out x cubed, leaving me with x squared minus 5x minus 6. And if I distribute the 5x squared in, I should have what we had before. I get minus 25x to the 4th. That looks good. I bring my 5x cubed down, and now we can factor this into a pair of binomial factors, I hope. That's factors x and x. I need factors of negative 6 that add up to negative 5. One will be positive and one will be negative, because a positive times a negative is a negative. So I put that 6 in there before I really wanted to. I know one is going to be minus and one is going to be plus, but the minus has to be bigger. Let's see if this works out. And sure enough, we get 5x cubed times the quantity x minus 6 times the quantity x plus 1. We check our smile, and sure enough, we get a we get a negative 5x. And so she smiles. So there's an introduction to factoring. We will work more and more in depth in factoring as the days continue, but that's a good start. We will see you in class.